This video is designed to help you work through the example number 2 in our probability flip chart. So this is an example of what is known as two independent events. Okay, this example involves tossing a coin and then rolling a die. Okay, and basically the fact that the toss of the coin does not affect at all what number you roll on the dice. That's why we call these two events independent. Okay, so I wanted just to quickly show you two different types of diagrams that might help you to solve this kind of a probability question. And one of those diagrams is just a simple table, and the other diagram is a tree diagram. So we've already talked about a Venn diagram. Depending on the question, sometimes a table's more useful and sometimes a tree diagram's also useful, depending on which one you feel is more effective. Okay, so if you decided with this question that you were going to use a table to help you to solve the different probabilities, basically what we're doing with these diagrams is trying to be able to somehow present all of the possible outcomes. Okay, so if I tossed a coin and then I rolled a die, I want to be able to list the sample space. And by sample space, I mean all of the possible outcomes that I could obtain by performing this experiment. Okay, so if I was doing a table, I could set out something like this and say if I rolled the die, if I tossed the coin, I could get a head or I could get a tail. And then if I rolled the dice, I could get a 1, a 2, a 3, a 4, a 5, or a 6. Similarly, if I tossed a tail first on my coin, I could get a tail and a 1, or a tail and a 2 on the dice, and a tail or a 3, a tail and a 4, a tail and a 5, a tail and a 6. So in this experiment, we can see by the little quick display of the sample space there, from that list I can see that there would be 12 possible outcomes in this experiment. And then it's very simple, straightforward to see probabilities from there. If you decide, I'm not that keen on a table, I would rather do a tree diagram, the same idea would work, that we say for our first event or our first experiment there, tossing a coin, I've got basically two outcomes. I could get a head on the coin or a tail. Now my second part of this experiment is to roll the dice, and if I do that, there are 6 outcomes. So it's a bit messy. I think for me, for this kind of question, I think I would go with the table because it's a little less messy. There's quite a few arms on this tree diagram. And with my die, obviously, 1, 2, 3, 4, 5, or 6. And the same 1, 2, 3, 4, 5, or 6. So again, if I was to list my sample space using my tree diagram to help me, as I read across the arms, I could go a head and a 1, a head and a 2, a head and a 3, a head and a 4, head and 5, head and 6, and so on. And then the same with the tails, tail and 1, tail and 2, and so on. Okay, so both of those methods of presenting the outcomes give us the same outcomes. So we end up with 12 outcomes, and then we can use those two diagrams to help us to calculate the probabilities. So again, if you're looking for a head and a 2, there's only one way you can get that out of the possible 12. Okay, so probability of 1/12. A head and an even number. So basically I've got a head and a 2, a head and a 4, or a head and a 6. Okay, so 3 possible correct outcomes out of a possible 12. So 3 out of 12, which would simplify down into its simplest form as 1/4. A tail and a prime number. So obviously, again, we do need to know what a prime number is. And a prime number is one that has only two factors, itself and 1. There are only a couple of prime numbers here with the tail. We've got a tail and a 2, a tail and a 3, and a tail and a 5. So we have, what's that, 3 out of 12 also. So the probability of 1/4. The number 1 is not a prime number, and the number 1 is also not a composite number. It's a special number all on its own. Technically, the number 1 only has one factor, not 2. Okay, that's why it isn't a prime number. A tail and a multiple of 3. So multiples of 3, obviously if we're counting by 3, they're the multiples of 3. So 3, 6, 9, 12, and so on. So the only multiples of 3 that are on this experiment with a tail, we've got a 3 and a 6. So for that part D, probability of a tail and a multiple of 3 would be 2/12 or 1/6. And a head and a number greater than 1. So again, a head and a number greater than 1, 2, 3, 4, 5, 6. So we have 5 possibilities out of 12 possible outcomes. And a tail and a number less than 3. So again, less than 3, 2 or 1, with a tail. So 2 out of 12, 1/6 again. So pretty straightforward questions. I guess the key to answering a question like this one is to be able to do some kind of diagram that helps you to be able to see fully the sample space, and then you can solve the problem.